Then I'll get you that worksheet and work on it today in class. So a rhombus, all these are going to start the same way. So a rhombus, we're going to define it as a parallelogram. That, so write down a parallelogram that. And parallelogram, 2 L's in there. So a parallelogram that has all 4 sides congruent. So it's a parallelogram that has all 4 sides congruent. And then the rectangle is a parallelogram that has all 4 angles congruent. And they're all equal to 90. So it's a parallelogram. And then a square is a parallelogram that has all 4 sides and angles congruent. So see how we have rectangles and rhombuses kind of on the same plane over here, and then the squares are both of those properties. So that's what that diagram is showing. Oh. So one is all sides equal, the other is all angles equal, and then the one on the bottom is both. Okay? Okay, so there's some theorems about rhombuses and rectangles. So a parallelogram, so we've already we're being more specific. So instead of just talking about a quadrilateral with 4 sides, a parallelogram, so that's a quadrilateral with both pairs of parallel sides, both pairs of sides being parallel. But a parallelogram is a rhombus if and only if its diagonals are perpendicular. So if its diagonals hit in such a way that you have a right angle there, then it is a rhombus. So for a generic parallelogram, that's not necessarily true. It doesn't have to hit at a right angle. You can really stretch it out. It is true that the diagonals bisect each other, but they don't have to hit at a right angle. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So what that means is this parallelogram is a rhombus, meaning all 4 sides are equal, if and only if each diagonal, so here are the diagonals, bisect a pair of opposite angles. So that would mean that diagonal bisects those 2 opposite angles, splits them into 2 equal halves, and this other diagonal bisects those 2. And then a parallelogram is a rectangle if and only if its diagonals are congruent. So if this diagonal is the same length as this one, then it has to be a rectangle. All right, decide if the statement represents a parallelogram, rhombus, rectangle, or square. So find that little, and you can have more than one answer, is what it says on there. So that means it could be more than one. So, for example, if the quadrilateral, so we're just think of it as a quadrilateral. So if the quadrilateral is equilateral, so in other words, the quadrilateral has all four sides equal. Now, what could it be? Square. It could be. What else could it be? Rhombus. It could be a rhombus as well. Yeah. So rhombus, because rhombus has all, equilateral means just the sides are equal. Doesn't say anything about the angles. So it could be a square, you're right, it could be a square, or it could be a rhombus. So if we're going from most specific on that, it's vice versa, it could be a rhombus. It's equilateral, it's a parallelogram. It could also be a parallelogram. So it just, the only thing it wouldn't be of these listed here wouldn't necessarily be is a rectangle, because a rectangle does not have all sides equal. So rhombus or square or parallelogram. I think all of these are at least a parallelogram. But there might be one on here that it's only a parallelogram and then the others. So what about opposite sides are congruent? If the opposite sides are congruent, if you go back to, it could be a rectangle, opposite sides are congruent, yeah, it's true. Could it be then a square? Rhombus, yeah. What about parallelogram? Is there a theorem that says in a parallelogram if the opposite sides are congruent? There is. So it's all four. You can just write all four. And the diagonals bisect each other. So when do the diagonals bisect each other? Rhombus. Okay. What else? Parallelogram, yeah, that's true. That's true. So if it's true of a parallelogram, then it's all four of them. It's going to be all four. Parallelogram, when we're talking about diagonals at least, we're not saying anything about the angles. So it's all, this is all four. All right, diagonals are perpendicular. So that's not necessarily true for a parallelogram. It is true for a rhombus. What's the other one it's true for? What about a rectangle? But the square is the other one. So rhombus is square. And then E, it is equiangular. So that means it's kind of like A. So it's equiangular. It could be a square or rectangle, yeah. Not necessarily a rhombus, a square or rectangle. All right, should we actually do a little bit of that? All right, it says find the value of x. So here we go with a bunch of setting things equal and solving, or setting them equal to some angle measurement, probably a 90. So right here, ABCD is a square. 4x plus 10. Can you tell where that is in your picture? Is that on the side? Is that has it perfect? So that's a degree measure. So the fact that ABCD is a square means we'll do what to solve for x? Yeah, so equal to 90. So we've got 4x plus 10 equals 90. So we're going to use the fact that it's a square, and that angle B is equal to 90 degrees. It hits 20, x equals 20. So it's just asking us to find the value of x, which makes sense because I already know angles measurements are all 90, right? I'm just trying to get you to set up and solve an algebra equation based on these geometric definitions of theorems. So in B, based on this picture, these opposite sides are equal. So 3x plus 4 equals 25, and then solve for x. So 3x equals 21, x equals 7. All right, A, B, C. Looking at C, the x squared plus the ORSP is a parallelogram. The x squared plus 11, I'm thinking, is this piece right here. And then the 36 is this piece. So the fact that it's a parallelogram means those have to be equal. Okay, so it's 7 equal. So x squared plus 11 equals 36. Subtract from each side. X squared equals 25. Does you should have a plus or minus 5. So plus or minus square root of 25, which is plus or minus 5. Does the negative 5 work if you stop the breaker? Can you plug in the negative 5 here and still get a positive 1? You can, right? Because when I square negative 5, I get positive 25. Plus 11 is 36. So x equals plus or minus 5. Either one would work. All right, and then EFGH is a rhombus. These look like two consecutive angles. So what must be true about the two consecutive angles?
Equal 150.
Yeah, so x plus 115 equals 180. Subtract 115, x equals 65. This is something we've done before. It's just setting things equal to 90 or 180 or to each other. All right, the diagonals of a rhombus are 12 and 16. So what is the side length? We need a picture for this. So diagonals of a rhombus. So I've got a rhombus here. I got to make sure my rhombus looks like it's a rhombus. So do those four sides look equal? Absolutely. But I don't want it to look like a square, because we don't want to assume that. So then we've got two diagonals here. We've got this diagonal and that diagonal. The diagonals bisect each other. And not only do they bisect each other, that's just the case for all parallelograms, but they make a right angle here. And that's the key to this problem. So the diagonals bisect each other. That will give us the lengths of these. So if this one from here to here is the longer of the two diagonals, right, from here to here is the longer of the two diagonals, and the whole diagonal is 16. Okay. What's the length of each one? Yeah, so we've got an 8 here and an 8 here. And then if this one from here to here is 12, the 6 and the 6. Have I mentioned Pythagorean triples?
Yeah.
This is a multiple. So there's a 3, 4, 5 that always go together with right triangle. This is a multiple of that. It's a 6, 8, 10. So because these triangles, all four of them, are right triangles with the lengths of the legs being 6 and 8, the hypotenuse has to be 10. If you didn't recognize that it's a 6, 8, 10 Pythagorean triple, what you would do is call this x, and you have 6 squared plus 8 squared equals x squared, and you would solve that for x. So I've got 36 plus 64 equals x squared. 100 equals x squared. In this case, I'm only taking the positive square root of 100. So x equals 10. If you can recognize those triples, I think a lot of the problems that they ask in worksheet and things like that involve some of these triples. If you can recognize those, it'll avoid having to do the Pythagorean difference. All right.